Hare Krishna. Hi everyone, welcome.
In this video, we are going to implement a Java program to find the missing element in array. We'll first understand what is the meaning of missing element in array. Let's take an example of array having the element 1, 2, 3, 5. We can see that all the elements in this array are present in a sequence and 4 is missing in that sequence. We need to find that missing element from the given array using Java. What is the logic we need to implement to find the missing element? It's very simple. Find the sum of elements of an array. We have 1 plus 2 plus 3 plus 5. These are the elements present in array and sum is 11. And we also need to find the sum without having the missing element. So 1 plus 2 plus 3 plus 4 plus 5. The sum will be 15. How do you finally find the missing element? By just subtracting the sum without missing element minus the sum of elements present in an array. That is 11. 15 minus 11 is nothing but 4. Let us practically implement this program using Java. First we'll add main method. We'll declare and initialize an array of integer type. We name it as array ARR having the element 1, 2, 3, 5. First, we'll find the expected sum of arrays without missing element. We need a variable to store the sum of elements of an array. Create and declare a variable of integer type and initialize it to value 0. We call it as expected sum of arrays. Now, we need a for loop to find the expected sum of elements of an array, assuming that there is no element missing in array. We need to perform sum of elements from lower range to the higher range, that is from 1 to 5, 1 plus 2 plus 3 plus 4 plus 5. We need to perform this addition using for loop. Let's add a for loop. Int I is equal to 1, I less than 5, I plus plus. The expected sum of array is equal to expected sum of array plus I. Each time we take the value of I, add it to the expected sum of arrays and store it into a same variable. Here we are not taking the elements of an array. We are just taking each and every number from 1 to 5, incrementing each time by 1. Then we find the sum of all the elements from 1 to 5. Next, we need to find the sum of missing elements in array. For that, again we need one more variable of integer type. We call it as actual sum of array and we initialize with the value 0. Now we'll again use a for loop to take each and every element from array and add it to the variable actual sum of array. Here we can also use a normal for loop, but I'm using a enhanced for loop in this example for int a colon array. So each time we take the elements of array, store it into a variable of integer type a, and each and every elements which is present in a will be added to the actual sum of arrays and store it into a same variable. Now we will have actual sum and expected sum. Finally, we print missing element in an array using system.out.println. Expected sum of array minus actual sum of array. That is nothing but 4. Let's run the program. You can see that actual missing element in an array is 4 printed in the output. Instead of having the hard-coded value 5 in the for loop, let us change the condition, make it dynamic by changing 5 by the value present in the last index of array. Therefore, I less than array of rln minus 1. Let's rerun the program. Actual missing element in array is 4. Still, we are having hard-coded values in the for loop. You can see that we initialize int I is equal to 1. There is chances that in the given array, 1 will not be the first element of an array. In such a case, this program will not work as expected. Hence, we change the hard-coded value 1 by value present in the 0th index of array. Int I is equal to array of 0. Let's rerun the program. Actual missing element in an array is 4.
Thanks for watching.